Hello, this is Mrs. Moslick, Geometry Notes 7-3 on similar triangles. Pause the video, do the warm-up. When you are done, go ahead and play the video. Okay, so hopefully you had some time to do this problem. Answer is C. Reason for that is alternate interior angles are congruent. We are given that these two lines are parallel, or line segments. And then this is by the isosceles triangle theorem. Base angles are congruent. And then by the supplement theorem, we know that angles that are forming a linear pair, so x and 35 are a linear pair, they are supplementary by the supplement theorem. So our final answer here is 145. Okay, let's go ahead and talk about similar triangles. State the triangle congruence postulates and theorems. We have 4 of them. Do remember proofs. If we want to prove that two triangles are congruent, we're going to either use side, 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 or side, angle, side, or angle, side, angle, or angle, angle, side. You can also call that side, angle, angle. You can put those 4 in any order. Once we know two triangles are congruent, think about a triangle congruence proof. Once you have the two triangles are congruent, then we know that CPCTC, meaning corresponding parts of those congruent triangles are congruent. So the corresponding sides are congruent and the corresponding angles are congruent. So let's write this down. Corresponding parts, the corresponding parts meaning the corresponding angles and sides of congruent triangles are congruent. That is all congruence, okay? So now we're going to be talking about similarity. Similarity is we'll either have a side, side, side similarity, meaning corresponding sides are proportional, or angle, angle similarity, corresponding angles are congruent, or we'll learn today new side, angle, side similarity. What can you conclude when two triangles are congruent? You can conclude 2 things. Corresponding angles are congruent. Corresponding angles are congruent, but corresponding sides are not congruent. Corresponding sides are proportional. It is necessary when you state the similarity postulates or theorems that you have to use a symbol for similarity at the end because it's different than congruence. Congruence, all corresponding parts are congruent, whereas with similar triangles, the corresponding sides are proportional. So if you are given 2 sets of corresponding angles are congruent, then by angle, angle similarity, the 2 triangles are similar. You can also conclude that by triangle angle sum theorem test, the 3rd set of angles are also congruent. So you can either say angle angle similarity or angle 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 similarity. Both are correct and both are fine to use when you are given this relationship of at least 2 sets of corresponding angles are congruent. Side, side, side similarity is when corresponding sides are proportional. So like, let's say these 2 sides form a ratio that equals the ratio between those 2 sides, which equals the ratio between those 2 sides. Okay, and then we have side, 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 and side, angle, side, and side, angle, side. We have, again, we're going to have 2 sides are proportional and their corresponding included angle are congruent. So like, let's say that these 2 sides form a ratio that equals this ratio. That's a side, angle, side. Let's go to the back side and use these 3 ideas. Number 5, are the triangles similar? If so, why or why not? Now remember, for similarity, we either have side, side, side similarity, or we have angle, angle similarity, or side, angle, side similarity. Let's look here. If we have parallel sides, we know that we have the alternate interior angles are congruent. So let's just mark up our picture. So we are familiar with the transversal being a different color. So now I know that by the alternate interior angle theorem, we have red and blue angle is congruent to red and blue, and green and red is congruent to green and red. So yes, the triangles are similar by angle-angle similarity, and we use the alternate interior angle theorem to show this. You could have also included the vertical angles. So you could have also written down vertical angle theorem, and you could have also said angle similarity. Number 6, are the triangles similar? Well, if you have overlapping triangles in this class, you are required to redraw them. So redraw them. We have TOR with an 8 and a 10. We have SOM, and 4 plus 8 is 12. 10 plus 5 is 15. And they both have this included angle. So if they are similar, it'll be because of side angle side similarity. Let's figure out if there is a ratio that is equal between two sides. So 8 corresponds to 12, 10 corresponds to 15. So 8 is to 12 as 10 is to 15, both reduced to, let's see, we're going to divide top and bottom by 4, top and bottom by 5, and both reduced to 2 to 3. So yes, those two triangles are similar by side angle side similarity because there is the ratio between two sets of sides are proportional, and their included angle is congruent. Number 7, again, just like in number 6, we have overlapping triangles. It is required in this course that you redraw the pictures. So we have CAS and CLM. This is a very calming problem. Can you tell? Calms. Okay, so CA's length is 5. 5 plus 2 is 7. This is CS is 8. And 8 plus 3.5 is 11.5. They also include or share this angle. So we would say yes by side angle side, but let's just double check that the sides are proportional. So you have to show this. So our first over second equals first over second. Again, it is really important that you code the corresponding sides. I like to use circles and triangles. Okay, so first over second. So that's 5 over 7 and 8 over 11.5. So we have 5 divided by 7 is about 0.714, blah, blah, blah. 8 divided by 11.5 is 0.695, blah, blah, blah. Now, geometry, mathematics is exact. Are those equal to each other? They are not equal to each other. Therefore, there is not a common ratio between the two triangles. So there is not a scale factor. So no, the triangles are not similar. Number 8, are the triangles similar? Yes, they are definitely similar. Really quickly, can you see? We're going to redraw the two triangles. The two triangles have angle similarity. So that's easy. You don't have to do any ratios there. However, to find x, we will have to do a ratio. So we have 5 and x and 3 and 12. So again, first over second equals first over second. So I code that, and then I'm going to set up my proportion first over second. So circles, 5 over 3, and now triangles, x over 12. Cross multiply, 3x equals 60. Divide both sides by 3, so x is 20. Hopefully you enjoyed that problem. Again, when you see overlapping triangles in this class, you have to separate them. Number 9, Olivia is standing next to a building. She's 6 feet tall and has a 9-foot shadow. The building's shadow is 322.5 feet. How tall is the building? So we have, let's see, here's the building. Here's Olivia standing next to it. There is a shadow So we would assume that the shadow, at the same time, so this is the situation, okay? It would probably be easier to just draw two separate pictures right away. So she is 6 feet tall, has a 9-foot shadow. The building shadow is 322.5 feet, and we don't know how tall the building is. So we have first over second, first over second. So first triangle over second triangle, or you can say left over right, or however you want to label them, but you have to label your proportion. And so we have x over 6 equals 322.5 over 9. Cross multiply, 9x equals 6 times 322.5 is 1935. Divide both sides by 9. So we get 215. And let's just make sure we've answered the question, how tall is the building? X, so that would be feet. So you do have to use labels, the units. Okay, again, hope you guys enjoyed this lesson. If you have questions, go back to the video. Also ask questions. Have a great day and enjoy your practice problems.